Welcome back. This is the next video where we are joined by again Tamal. Hi, Tamal.
Hi, Amber. Nice to meet you.
Thanks. And his team, Dipto, Abdullah, and Dipta. Today we will be focusing on the live lab and a wonderful demo that we will set up to beautifully kind of, aggregate whatever we have been talking about. Tamal, any thoughts from you?
Yeah, I mean, we kind of already went over these various products that we have in terms of the KubeDB and Stash and Vault. So now we get to see this in live action. So look forward to this and see how everything goes with the demo, live demo it is.
Yeah, as I always say, this is a live demo. Things may not work. Well, it gives you a chance to understand the products better, solutions better, and a bit of troubleshooting, right? So don't throw it in the room or under the bus if you think it's not working. Anyway, let me share my screen. I hope you're able to see this. This is the page where we were spending a little bit of time in the previous video. We will start with deploying two clusters. Like I said, cluster M1, cluster M2. These are two EKS Anywhere clusters running in my on-premises environment. So let's get going. I'm on the terminal, okay? And if you've been following the blogs, the procedure to create a cluster is very simple. I will run a script which will allow me to define a cluster and configure it and then run it to its execution. So I'm naming the cluster as M1. Let's give it a API IP address of 10.204.111. Let's say 55. Now there are two clusters. The first one that I'm going to be creating is going to be a smaller size cluster. It will only host our centralized vault through Kube Vault. So obviously, we can afford to bring in a smaller cluster as such. So I'm going to use this template called as consolidated. What it will do is basically two worker nodes is what it's going to run. Let's put in the version. And there we go. The cluster creation process has started for M1. Okay. At the same time, I will switch over to another terminal. Okay. And I will do a similar repeat of creating the cluster. And this time I'm going to name the cluster as M2. And this is going to be the cluster that will run most intense workloads from the entire sock shop, application footprint, persistent volumes, and many other different things, operators and whatnot. So this time the cluster is going to be slightly bigger. So 10.204.111.58 is the IP address that I will give it. And like I said, the cluster is going to be bigger. I will be bringing in roughly 8 worker nodes and 3 control plane nodes and 3 etcd nodes. So that makes roughly a total of, not roughly, exactly a total of 14. Am I correct, Tamal? My math is correct, right?
Yeah, 14 nodes.
14 nodes is a good number and it represents a decently sized cluster, at least for this lab. You could go in with a smaller one, but let's see, we'll work with this one. 1.25, and there we go. This will take roughly 12 to 15 minutes for both the clusters to come up and get ready. And while that happens, actually, we will be pausing the recording and resuming it when the process is completed. But before we do that, I think it's important to know how this particular cluster is built out. The one that you see here, M2, it's primarily divided into node pools. So there are two worker nodes that will be hosting the persistent services, and then 6 others which will be hosting stateless services. That's how the combination is. So it's MD0, MD1, and MD2. These are 3 node pools in the cluster that we will be creating actually. Okay, let me pause the recording and resume when we are back. Okay, so say about 15 odd minutes, and both the clusters are up or created at least. So you can see cluster created and the second cluster here, cluster created. So both clusters seemingly good. Let's just quickly set the kubectl context so that I can work on these terminals adequately. And like in the previous blog, I don't have to go through anything and everything. I just have a simple script. Let me say switch cluster M1. Let's see if I can access my cluster. So you can see that 5 nodes have come up. This is the smaller cluster M1, 3 control plane nodes, and 2 worker nodes with the prefix of the cluster name and MD0. That's the node group label. Okay. The EKS core distribution in the form of EKS anywhere. Okay. Let's see the other cluster here. Okay, source switch cluster M2. kubectl get nodes. Now we can see here I have the etcd nodes will not be shown because they don't run the kubelet. They are a dedicated separate because of a production simulated environment. Otherwise I can simply consolidate the etcd also into the control plane nodes, but that's not the case here. So what we have here is 2 control plane nodes and then 3 MD0 nodes, 2 MD1 nodes and 2 MD2 nodes actually. So these are the node pools actually. Again, same thing. Okay, so we are ready from a deployment standpoint, but what are we going to deploy? The starting point for this will be deploying our CSI drivers. Now, a short word or note on the persistent storage that we will be used for this live lab. It's the Dell PowerFlex, which is a highly potent platform. And I don't know if you've seen the previous blog, but I have mentioned a complete hybrid data plane construction between a PowerFlex running inside of Equinix on-premises and then a PowerFlex running inside of AWS as Apex block storage over AWS. And we built out a hybrid data plane having EKS anywhere and EKS in the public cloud, talking to each other, doing replication and things like that, right? So it was a very interesting blog. If you get the time, you can go and hop over that blog. Now, this is going to be our home for all the persistent workloads. Okay, as of now, the Kubernetes nodes that will be talking to this particular storage, they don't have any CSI drivers implemented. So our first task will be to deploy the CSI drivers. So let me take this particular script here. Again, we can do this in a very manual sense or script it out. So it's a short script. It's available on my GitHub repository for EKS Anywhere. You go into PowerFlex subdirectory and you will find the script there. So I'm going to say, take the script, run the script. These are some of the variables that I'll talk to you about, but let's see now. Let me go over to the run of the script here actually. Okay. Let's go to cluster M1. Okay, I'm just going to run this particular script. The script is asking me which is the cluster name. So cluster name is M1. The release number for the CSI drivers actually. So Dell maintains a strong affinity to the Kubernetes release mode roadmap. I'm going to run 2.6.0. And then it asks me for the IP address of my PowerFlex cluster, which is the endpoint. And for that, I'm going to give it 10.204.111.91. The cluster is already set up and running. You saw it in the GUI. So this is the IP address for the endpoint. In the previous blog, also I've mentioned that there is a set of metadata managers inside of the PowerFlex cluster, and my CSI drivers need to be able to talk to those metadata managers to actually reflect the state of the cluster, all a resilient architecture, right? So let's just, instead of typing it out, I will just copy paste. These are the IP addresses, the 3 metadata managers that are running inside of that particular cluster. I will take these IP address 85, 86, 87, run it here, and then the system ID for the PowerFlex cluster. I'll take this value and paste it here. Okay. The username and the password. And where will be the CSI drivers installed? So as you saw it in the node pool group, there were, and I correct myself, there are 3 MD0 nodes. I think in my initial pitch I said 2 MD0 nodes. So there are 3 MD0 nodes, 2 MD1 and 2 MD. So MD0 is particularly earmarked for running persistent workloads so that we can create some kind of logical isolation. And this is where the CSI drivers will also get installed. Instead of spray painting them across and then running persistent workloads across the 8 nodes or 7 nodes, we will run them on these 3 nodes only. So I'm going to give the node selector as MD0. And you can see the script execution has started. Okay. While this happens, we will do the same thing on the other cluster. So let me take this particular script again. I have to be a little careful here. I'm working with 2 terminals. So keep me informed if I goof up something. Okay, we don't want to spend time troubleshooting unnecessarily. So I'm taking it on the other cluster. This one is M2. Okay, same thing, 2.6.0 as the CSI release number, 10.204.111.91 as the cluster's IP address, and then the metadata managers, 85, 86, 87, system ID, username, password. Let me be a little careful with this. Yes, and MD0. Okay. So on both the ends, we can see that the CSI drivers. So you can see here clearly that eventually it says a success, right? So everything is working here. Okay. In addition to that, the script has also installed a PowerFlex storage class and a volume snapshot class in case we want to take snapshots and things like that. For now, I will just verify this. kubectl get pods -n vxflex OS. So you can see that the controller pods and the node pods are running. So all good. We are on M1, 2 worker nodes. So 2 node pods running as a daemon set. Okay, let's see it on the other end. So success. Okay, let's verify this. kubectl get pods -n vxflex OS. So you can see here 3 node pods, which means 3 worker nodes, MD0. And controller is whatever we defined it in the templates and all that. So we are good with the CSI installation. You can see it's pretty simple, but very powerful. It gives you the ability now to drive. PowerFlex is a beast mode platform, 16 petabytes per cluster and millions of IOs. Enough benchmarking and proof pointing done on the internet. And you can see how easy it was to actually integrate our EKS Anywhere cluster with PowerFlex platform. And we will see all this in action as we start to deploy the workloads. More and more information will be shared on this. Now, the next thing that we will do is to install MetalLB. Now, this is a private network. Okay, I'm not on public cloud, so obviously I need a load balancing capability. So I'm going to go and deploy MetalLB as my preferred choice of a load balancer. If you have not worked with MetalLB, I think it's a very powerful way to express your networking for Kubernetes in the private data center space, actually. Okay, so on the first cluster and also on the second cluster. Okay, so we are going to deploy MetalLB. It should take a few more seconds, let's say that. Okay, while this happens, once MetalLB comes up, we will have to configure what are called as MetalLB advertisements, and this is the address range that will be given to the external load balanced services. So all the services that I deploy, like in AWS, you will be getting a NLB association. Here we work by IP address, and then we can do DNS, manual entries or automated through Kubernetes CRDs. So these are the IP addresses that we will be working with. Not too many, but two, mainly because we will put an Nginx ingress controller also. So everything primarily will be based on ingress routing. So this is the address assignment for the first cluster. This is the address assignment for the second cluster. Okay, we are working in an ARP mode, and not the BGP mode of MetalLB. There are two modes that you can actually deal with. So let's take this particular advertisement, and I will hop to my first cluster. Okay, let me see if the pods are indeed ready. MetalLB system. So you can see that because there are 3 control plane nodes and 2 worker nodes, 5 nodes. So a daemon set is spread out there actually. Okay, the controller is a single controller. We can increase the number of controllers. Now we will put the address assignments through the advertisements. Okay, so this is the first one, and I will take the address assignments for the second one as well. Do this onto M2, kubectl get ports, MetalLB system, all clear. Let's paste in the address assignment. Sometimes copy paste could be a disastrous thing. So let me just verify this. Okay. So these are done, which means now our MetalLB is listening to all service requests or services created of the type load balancer. And if there is one, it will assign one of these IP addresses. I can have, tens, hundreds of IP addresses. Here I have only 2. Now what we will do is we will deploy a Nginx ingress controller on both the clusters actually. And I'm making sure some of the SED commands are there to ensure that I have the ingress controller also coming up on MD, because the other 2 MD1 and MD2 nodes are designed for auto scaling. Right, so I don't want this auto scaling pattern to disturb the controller. So all the controllers, to the extent possible, along with the CSI drivers and whatnot, they will reside alongside the persistent workloads on MD0 node pool actually. So let's take this particular command set. Go here on the first cluster. Okay, let me just see. So let me go back to the cluster itself. Let me go here. Okay. So as you can see that the ingress controller has also been created. And alongside, there are a number of CRDs that will actually be fitted in. That's also done here. Let me go to the second cluster and repeat this command set. And on both the ends, basically, we will get our the ingress controller done. And we can quickly see kubectl get service -n ingress Nginx. So you can see that MetalLB has already given it an IP address from that range. It is 56. And for the other cluster, kubectl get service minus and ingress nginx. Here the MetalLB has given for the second cluster based on the address pool .59. Okay, so we are good here actually. So we are done with two things actually. One is the CSI driver. Second is actually three things: CSI driver, MetalLB, and the Nginx ingress controller. Okay. From here on, we will deploy a metric server, which will help us do, if required, horizontal pod autoscaling, and also a cluster autoscaler, which will help us in tandem actually. So both will work hand in glove actually to create, very responsive cluster based on peaks and troughs. We can do various things in the cluster. Okay. Let me deploy the metric server first. Slightly painful to toggle between windows, but nevertheless, let's continue. Okay, so I'm just going to deploy the metric server here. You can see even the metric server pod will be coming up on MD0. Like I said, I try to maximize the MD0 group for all controller actions actually, and not let them interfere with the stateless applications actually. Okay, now I will do the same here. Okay, so both ends are done. We will deploy the cluster autoscaler. Now, cluster autoscaler, I know there are a lot of ifs and buts about how cluster autoscaler is shaping up as a project. Tamal, any views from you? I know there are, if you're working in the cloud, Carpenter is there, and a lot of now with the Gen AI or the whole AI run, there are so many good investments happening for Kubernetes autoscaling. In fact, I saw one good, for the upcoming KubeCon, there's a discussion about state of autoscaling in Kubernetes. So there's intelligence. Anyway, some thoughts from you will help there.
Yeah, I mean, I saw the same thing on X or Twitter. There's this whole session on going to be on autoscaling. I have been actually personally experimenting with the Carpenter, like even this week, trying to see how all it works. Because a lot of folks, especially on cloud, like they want to try this autoscaling with like maybe try spot instances as part of some of the workloads and things like that.
Yeah,
this is getting very interesting, and I think you probably also the Carpenter project also added support for Azure recently, right? So now it's not just AWS specific anymore. So it's getting very interesting to see how it all shapes up.
Yeah.
So one of the interesting things is the Carpenter doesn't work with like a cluster API yet, right? So we have to
exactly. So I think that's a very important mention that you have. Under the hood, it's all cluster API here, right? On EKS anywhere, and primarily on-prem Kubernetes, there's a lot of synergy for cluster API, and then cluster API has 50 other different providers it can work with. So all this momentum and the marriage of different ecosystem players, I think it's going to be a very interesting next 2 years to see where it takes place, and especially with the embeddings from an AI space. People are bringing a lot of artificial intelligence to run alongside, not for their workloads, but actually to orchestrate Kubernetes or to supplement that intelligence in Kubernetes. So for now, I'll take what it is. We'll take the cluster autoscaler and deploy it on both our clusters. Okay. Let's take this here. And also on the second cluster. So as of now, it will just deploy. It won't be actioning anything since we've not configured any specific HPAs and whatnot. So it's basically, just happy and sitting there monitoring things and whatnot. So at this stage, we're done with the metric server and the cluster autoscaler. Now, I'm using a slightly backdated version of EKS Anywhere. Else, in the new EKS Anywhere tooling, the default storage class has always been the vSphere storage class. Okay, Now, that doesn't mean that you can use only that, but it shipped in the previous avatars a default storage class so that when you are ready to deploy, you don't have to, if you have vSAN or vSphere based constructs, you can simply start deploying persistent workloads. But now that's no longer the case. Starting whatever Terraform version 19, I think, or whatever, sorry, not Terraform, EKS anywhere, they have removed the support for the standard storage class being vSphere actually. So if I have to deploy vSphere based storage class, I have to just run their operator and run. But in this case, since we are going to be using PowerFlex as the storage provider, I don't need to worry about that. So if I say kubectl get storage class, you can see that there are two storage classes and both are as default. So I'm just going to remove the standard one, which is based on the vSphere. Okay. And let's repeat the command, make sure that it's there. Okay, that one is gone. Also the same thing on the other cluster. So I'm going to remove the standard storage class. And let's just see what is the storage class now. We can see that on both ends or both the clusters, there is just one storage class called as PowerFlex SC. You can see the provisioner is CSI vxflexos.dell.com. That's the CSI driver reference that will be actually hooked onto the the PowerFlex array. Now we are done with these things. I have already I'm already running the customize. I've already deployed it on my CLI, so I will skip this particular step. We will need customize in your CLI. Now comes this, Kube Prometheus stack, which will be essentially required. Now, Kube Prometheus stack, I think, is one of the most popular stacks out there. Helps you deploy complete observability suite in sense of, both Prometheus and Grafana. So I'm going to take this particular thing here, right up till here, so that I create the values file. Okay. So on the first cluster, let me do this. Okay, so it's just going to update the repo, create a values file at both ends. Same thing here. On the second cluster, you can see that I have apps code chart repository also getting updated. That's one of the chart repositories we'll be using for all the KubeDB products. Now that the values file has been created, now there are two ways we can actually do this particular thing. One is directly deploy Kube stack, the monitoring stack directly from Helm. Instead, I'm doing a Helm template here actually. What advantage it gives me is a slightly more control over, how I set things in YAML actually. You could deploy it through a typical Helm process. So let me take this particular, I'm going to create a particular secret here. And this is going to be used for the ingress for the Grafana instance. Okay. And let me be from here where I create the secret for the, Okay. And because we are doing it through a YAML template, some of the CRDs, which are essentially a part of the Helm install, they don't get repeated or installed again, right? So I'm going to manually get those CRDs and just kind of take them and apply them. So let me copy it from here to here. And I am going to be on my first cluster. Basically, we are just downloading whatever is required for the Kube Prometheus stack to be executed. Okay. Now I will do the second thing on the M2 cluster as well. Okay. While this happens, the next thing will be to create these particular downloaded files, which are essentially the CRDs actually. So I'm going to take this particular, make sure that I copy it properly. Now I have mentioned it in the note saying that if you do a kubectl apply, there is a saying CRD size is large. I don't know what's going on, but We will do a create. Okay.
Yeah. I mean, when you do this kubectl apply, what it does, if you notice that it creates this annotation, right? Like last applied configuration annotation, and that annotation value is actually the whole CRD, and that it typically throws this error saying that this annotation value has like a max size limit, and that crosses, I think, and that's when you get this error. So when you do create, yeah, it doesn't create that annotation, so you avoid that problem. Yeah.
Right. So we will do a create of this at both the ends, and this actually, does a lot of different things, and it will take 10 to 15 seconds. Okay. Some of the CRDs are already there, so it will not override them. Now we will go back a directory and then install the, this template, install kubeprometheus as an output of the Helm template command. So now is what the actual installation of the kubeprometheus stack will happen. In the previous run, we just deployed the CRDs actually. Okay, so let me just clear this. Okay, and this will go on. I will go to the other one here as well and paste the same thing. So now we've done quite a number of things here actually. And while this happens, we will quickly recall. We started with CSI driver. We did the Metal LB, the Nginx, then the metric server, then the cluster autoscaler, and now we are on to the, so we removed the storage class. We are on to the kubeprometheus stack deployment actually. Now, once that happens, we will deploy the Grafana ingress. Okay, so I have a sample that is located in my GitHub repository. I'm just gonna copy that because we have two clusters, we will have to change the host name for the Grafana instances on both the ends. So we will take this particular template from my GitHub repo, copy it, do the replacements, and then create on respective clusters the Grafana ingress. Okay, let's go here. Okay, and I'm going to deploy the Grafana ingress here. And let's go here. Okay. Hey, this already exists, so I can ignore that error. And let's put the Grafana ingress on the second cluster also. Okay. So now, basically, if I look at it on both the clusters, my Grafana should be working. Okay, I have just put in a local host entry. This is my host file. We can do a DNS entry, but Grafana m1 cloudgarage.com maps to .56. .56, if you recall, is the load balancer IP for the ingress controller. And ingress controller will backend it to the host called as Grafana m1, which is what we just defined. Likewise, we have Grafana m2, and this time I did a mistake, so let me save this. Okay, so Grafana m2 will be on 59 and Grafana m1 will be on 56. Let's quickly validate this before we move ahead. We will not get into Grafana right now. And we are secured through a TLS, so we'll do HTTPS Grafana -m1 the cloud garage.com, just validating if it's working. It is. Okay, so we have Grafana instance ready for m1 cluster. Let's take the second one, Grafana m2 cloudgarage.com. And this is also working. Oh, okay. I think we have to still work out the second clusters one, but I'll see what is happening there, maybe the DNS or something. Okay, we'll see that again when we come to Grafana. Now, for now, we are done with this point. Next thing will be to set up the Kubernetes dashboard with ingress on both the clusters. It's not a compulsory thing, but I'm just going to take it and just keep it handy in case we use the Kubernetes dashboard. So we're going to take this whole set of commands and deploy it on both the clusters. Let me go to cluster 1. Okay. And also on the other cluster. Okay, so both the clusters have the Kubernetes dashboard setup. I can see that I can get the token from both of them, so not a problem. Now, this is where we will say our both clusters are ready for deploying all different workloads. The primary things that a cluster needs is adequate networking, which was MetalLB and ingress controller. It needs proper storage interfaces, which is our PowerFlex CSI driver, and it needs some supporting OSS capabilities and management capabilities, which we have the dashboard, the Prometheus and Grafana and all. So, and the capabilities for autoscaling through cluster autoscaler and metric server. So primary components are done. Now the interesting pieces start about, and we will see this in the next video.